Hello, this is Dead Hamster. Today we'll be doing a slightly different video. This will be covering how Mario Kart 64 works in terms of how the course data is stored in the ROM, how the game loads that data, and how it uses it to display the course and determine where the player is and what needs to be shown to the player. To give a more you know in-depth explanation of what I mean. When you're playing a game, an N64 game, any game really, you have a character, an object walking around, and then you have the camera, which usually can move around the player and see the environment, the geometry, and so the game needs to know where the camera is looking, where the player is in relation to that as well, and then what geometry needs to be drawn so that it's not drawing too much. Things that are off camera don't need to be rendered, and so there's no reason to be using any of the processing power to do that. So the way most games do that, again, is with a camera rotating, you have to keep track of the position of the camera and the orientation and all sorts of other things. For Mario Kart, you don't actually have that happen. With Mario Kart 64, you're always located, the camera, directly behind the player at a fixed height. There's two zoom levels, but other than that, there's no way to rotate the camera or move it in any way. I apologize for the slow frame rate. It doesn't quite like me recording at the same time, it seems. But again, you could still see here, the camera is going to be locked directly behind the player. It's not going to move in any way. So it's a very different way of controlling the game. And for that reason, the controller fell out here. For that reason, the game handles everything very differently. As you proceed across the level, you go across different sections, and in each section there are different views, north, east, south, and west. And based on what section you're in and what view you're in, there's something called a display list that's drawn. So we're going to back up now and go into, again, how the level data is stored in the ROM and how the game uses it. So when the game loads data from the ROM, there are four segments. There are several segments, but there are four that we're going to focus on that are used for course rendering. The segments are just collections of data stored at a specific offset in the memory. When the game needs to access data for any reason, it knows what segment it's in and what offset into that segment the data is stored. So it's very quick and easy for the game to access data regardless of where it happens to be stored at that specific moment in the memory. So for segment 4, you have the vertices, the verts for the course geometry. Segment 6 is a generic container for F3D commands. Now F3D is the microcode that that Mario Kart 64 uses to render its geometry, to do its 3D rendering. It's an advanced or an enhancement of the original F3D microcode that Super Mario 64 uses. It has some improvements to the vert cache that we won't really discuss or get into. I may refer to this throughout the video as FedEx code. If I do, this is what I'm referring to. It's just much easier to say than Fast 3D Express or Fast 3D Enhanced, whatever it is. So regardless, again, segment 6 is a generic container for FedEx code as well as any other object data that might need to be contained. For example, in Mario Kart 64, the sign that rotates and all the vertices and textures for the sign is stored in segment 6. In segment 7, you have the course geometry. Now, segment 4 and 6 are compressed with a generic, it's called MIO0 compression, sort of like zip compression. Segment 7 is very different, whereas segment 6 you had access to, you could store anything you'd want. Segment 7 is only for FedEx Fast 3D Express code, and it's only for very specific commands with specific parameters. Basically, the only thing you can do is load one of 6 specific texture types that has a specific width, height, and format. You get 6 options. You could load vertices, and you can draw triangles. Outside of that, pretty much everything else is cut out, and because of that, they're able to compress it down to a very, very small size using a special bytecode, basically, that condenses the data down. So segment 7 is only used for the coarse geometry, and it uses a special compression method outside of the normal ones. Finally, we have segment 9. Segment 9 contains offsets to all the textures that are in the course, as well as some basic parameters about the size of the textures. As well, some courses have what's called the master display list stored in segment 9. So again, with Mario Kart having the camera set up differently, it's very different than normal games having it stored. There is no single piece of geometry for the level data. It's actually broken up into a ton of different objects, and based on where you are in the course, there's something called a display list that will draw each of those objects. So to kind of help visualize it a bit, we have, depending on what course you load, there are all sorts of calls in the assembly language that load certain data out of the segments. For example, there's a list of where the trees, the piranha plants, and the item boxes are, as well as the paths that the AI follows and the paths that's used to determine where you are on the course, who's in first, second, third place. Then it also loads things like the master display list and the surface map, or the collision. For the master display list, there's, again, each course is split up into sections. In the case of Mario's Raceway, there's actually 17 sections throughout the whole map. And each section has 4 views. You can either be facing north, east, south, or west. To take a look at what that looks like, I'm actually going to go into a 3D editing program here and show you what Mario Raceway's entire surface map looks like. So this is where you would start the race normally in Mario's Raceway, and this would be the starting line area. This section here, this piece of road and the grass on the side, would be section 1. As you proceed into this blue stretch of road with the orange area, this would be section 2. And then as you would drive into that, you would load new display lists that would load new objects. Now when we're looking here again, this is north, and north has all these display lists that have all these FedEx commands. That can be shown right here actually. This is section 1 north. So if I was on this stretch of road facing north in this direction, right at the start of the race, for example, before the the go signal was thrown, this is the geometry that would be rendered. I would be right here, looking down. Now the crowd is always drawn. That's something that is done by the assembly actually. So I'd be looking here, seeing this, and then as I proceeded into section 2, this blue area, still facing north, I would then see this instead. And as you can see, there's some more things around the corner because I would have moved forward, and now these objects have to be drawn. You can see how each object too is separated. That is these individual display lists. So going back again, you can see in section 1, when I was facing north, there was all sorts of display lists that are called, and those display lists reference the F3D commands, the fanatics commands that drew these objects. You'll notice that these are named the rather weird looking segment and then an address here. These are actually what are called segmented addresses, and the way they work is that the first two numbers, the first byte, is the segment that it's in this case segment 7, and then the next 6 is the address. So at offset 4B50 into segment 7, you would find the commands that drew this. And you'll notice that for each view that has the same object, 4BB8, 4BB8, that uses the same object in the list, just repeats that object for east, southwest, section 2, whatever it may be, if it needs to draw it again. So what does this mean for us, and why am I discussing it? If we want to create custom courses, where, as you saw before, I was driving around in my own level that I designed, we can't just have a single piece of geometry and import it into the game. That's not how it's expected to be put in, unfortunately. What we need to do is take our geometry and split it up into 50, 60, 70, 100 objects, however many it may need to be, and then create the lists to draw which objects you are based on what section you're in. Additionally, we have to make the surface map, and that is similar to the display lists, but also a little bit different. So again, looking at the diagram we have here, for the surface map, it references a section, and the section also has data referencing what material it is. So for example, when I'm driving on the road, that's different than when I'm driving on the grass, which is different from when I fall into the dirt that tumbles you into the mud, or the water rather. So those are all different materials that have different effects, and that's determined on the surface map. Additionally, associated with each section and material is a display list. So when I'm driving on any of the polygons that are created by this display list, again, it calls a whole bunch of objects. So section 1 would call these two objects. It would only probably have two display list calls, actually. It would draw the road, and it would draw the grass. And if I was driving on the road or the grass, I would be in section 1. If I was driving in this part on the road or grass, I would be in section 2. And based on if I was in section 1 or section 2, it would then render, again, the appropriate sections display lists. How that looks, again, we would have, this is the beginning of the surface map. We have the segmented address to the display list right here. So in section 7 at offset 17D8, I have a display list that calls all of these display lists, and all of those draw triangles and objects, whatever it may be. That would be area 1, or section 1, and it would be material 1. Now with the materials, I'm going to reference the chart here that Micro 500 has made. For material 1, it's solid, used for pavement, tunnel walls, and the floor in Koopa Troopa Beach. In this case, it would be the road. So we're looking at section 1 road, 17D8. And if we actually look here, you can see 17D8 is the road right here, section 1. If we then look at 071770, we have still section 1, this time material 2. Material 2 is dirt in several courses, or the edge of water pools in Royal Raceway. And no, that'd be 1770 it said, right? Where's that? Well, that's strange. You know, I think I might be using the wrong one. But regardless, again, it's the section, the material, and then what area it's for. I might actually have it backwards, and that's why it's the material first. So this is the road section 1, the road section 2. So if I looked here, yes, 1770, that's what it is. So then the road section 3, 16D8, should be this object here, and it is. So I had those mixed up. I correct myself. It is the material first and then the section. So once we get all the way through to section 17, right here, no, that's, no, where are we? There we are. Once we get to section 17, we then have a different material. In this case, FF. What is FF? Also solid, used for walls and the ramps in Koopa Troopa Beach. So in this case, we're probably drawing some of these walls that would come up and block you from just cutting across the course. But again, the point is that each section would have a display list as well as some data relating to the section and the material that you're driving on. Based on what section you're driving on, calls certain objects. So we also have to create this out of the geometry that we make and the objects that we separate, and then set up that data for it so that it's properly drawn when the course starts. So quite a lot has to be done to some basic geometry before it can actually be rendered in the game and be made sense of by the way the game is expecting it. So instead, again, of having one single object, we have to have tons and tons of smaller ones. So for example, this is a course here that I was beginning working on, and you could see there's one single object as you would expect for most games, with triangles and polygons with different materials and UV mapping and interconnecting, but this is unfortunately not good enough. Instead, we have to separate it based on material and based on where it is in the course. We also have to create the sections. I've actually already done that, so I'm going to import them from a goodness, this will be a mess. That way I don't have to do all the work. I can just show you what it's supposed to be like. The video is going to be quite long enough as is. Don't need to spend any more time than we need to. There we are. Actually, I suppose I can go right from here. So the way that we handle this, we have a list of all the objects in the course, split up, as we said, by material and where they'd be viewed from. And then we have each individual view and section, for example, section 1 north. would be the objects that we're able to see when we are on section 1. I've highlighted section 1 right here. So anytime that I would be driving on any of the objects inside of this highlighted area, I would be considered to be in section 1. And this would be considered facing north. However, this is also facing north, and this is facing north because of up to 45 degrees before you turn east or west. So if I was, for example, at the very edge of here facing this direction, I'd want to make sure that I can at least see these cliffs and these things around the corner, so that as I'm approaching the bridge and approaching section 2, things don't pop into view suddenly. So you do have to make sure that certain objects are viewable, even if it might not seem that they would normally be able to be seen. The way that we get these, I'm actually going to show now. We'll just take a minute or two. We're dealing with quite a large number of objects, so it is very difficult, and does take a bit of a stronger computer than I have, I suppose. Get rid of those. So we're just deleting the parts that were already there, and we're going to reload them. There's an automatic process we have that kind of does a very roughshod attempt to assume what would potentially be viewable. Again, it's very rough, and that's intentional. It's much easier to delete objects than it is to add them back in. So I'd rather it grab objects that there's no way that you could possibly see, and then you can quickly delete them, as opposed to not getting a whole bunch of objects that I do need, which is then more tedious to add in later. But we'll see that now. So we first do have to make sure that the entire course is separated into sections. So as you can see, even the courtyard area back here is a surface. We have another one if the player was to go off to where Mario comes in. Another one for this area if they were to tumble down here. Another one for this area if they go off the course to the left. One for the bottom, the moat. And then there's 10 for the actual course that go through the whole You'll notice that it doesn't necessarily contain all the geometry. It just contains what the player will be able to collide with. It's just for the surface map, just the surface geometry. So what the script will do, it's going to take every vertex, every vert on each surface map, and it's going to compare them to the vertex of every object in Course Master Objects. If a vertex is further east, north, south, or west of any of the vertices on this surface object, then it's going to add it to the list. As I said, that is very rough, and it's going to get a lot of false positives. A huge number of false positives, for example, if this is looking north. It's basically going to get the entire course, because everything is north of this vertex. Again, it's very easy to delete objects, a little bit more tedious to add them back in. So we're just opening the Overcart Max script. We've already set up all of our surfaces, and we should be able to just hit Automate Section Views. And there it goes. So as you can see, it goes through each section, each object, each vertex, and it does it 4 times for each view, north, east, south, and west. So as this is going, I'm going to take some time to look into display lists and how they work, so that we have a bit more understanding of those. So again, this is a reference to a display list. A display list is a FedEx command that points to another command. What it basically says is, hey, this needs to be processed too, so that the whole object can be drawn. As an example, if I was drawing this tower and I was drawing this white brick section, but I also knew that I needed this red section here, this orange one rather, as well as this white brick in the top, I might have the display list for this tower at the very end have another call to this one, which then would call that, which then could call the one on top. That might be a way to set it up so that every time I called this, I knew that the entire object would be drawn. Not necessarily what you want to do, just an example of how these display lists work. So when we're discussing the master display list, which we kind of glossed over earlier, each section, again, we have 17 for Mario's Raceway. I have 10 main sections for my course. It has 4 views, and each of those has multiple display lists, which all call FedEx commands. How that would look would be something like this. So the FedEx command for loading a display list is 6. It's the number 6 with nothing following it. Then you, after that, immediately have the segment address. In this case, in segment 6, at offset 1D0, you would have section 1 north. And then at oh no, I apologize. This would be for section 1 north here. It does, same as in here, it does not actually have the call for the display list, which ironically is 6. So in this case, again, it's in segment 6 at offset 0, which I can actually go right to. So this whole strip here loads up some segment pointers and some textures, and then we go right here. As I was saying, the number 6 is for loading a display list at segment 7, 1770, which we spoke about earlier. As soon as it finishes processing this call, it comes right back here and goes to the next one. 16D8, 1950, 17D8, 5218. It continues calling, processing FedEx commands until it comes to a B8. A B8 command stops it immediately. And then it goes back, in this case, to here. So section 6 north, or I'm sorry, section 1 north is this here, and all of these 060s and then the 07s are display list calls, which we were looking at here. So it calls a display list, which then has all these FedEx commands that then comes back, and then it calls another display list, which has all these FedEx commands. And by doing that again and again and again and again, you draw an entire view based on, again, the player's location and the view that they're facing. So we're just about finished here. It looks like we're on section 15. So we'll watch it wrap up as it processes the south and then the west. Now I've taken, I haven't fully completed actually making the surface maps. You notice there's only one object. There should be one object for every material. The way that Overcart, oh, here we are, took 5 minutes and 3 seconds. Very nice, thank you. The way that Overcart processes objects, and Overcart is the program that I've written based on a whole bunch of other documentation and help from a whole bunch of other wonderfully smart people who are all listed right here. Overcart draws materials or one object at a time. So it doesn't change materials between objects. There are two big bottlenecks. As far as I know, the two main bottlenecks that are existing in F3DX, FedEx is loading textures and loading data. Anytime you have to load data from the segment or from the ROM or RAM in order to process it, it takes a lot longer. Unfortunately, the registers in FedEx are very small. For vertices, you can only hold 32 verts at a time, and that's not a lot to work with. As you can see, my course has 3,000 verts. So in order to process that, you have to load verts, draw triangles, load verts, draw triangles, load verts, draw triangles. And the more times you have to load verts, the slower it takes to draw the entire course, and the less performance you get out of this. For example, DK Jungle Parkway is terribly made. References textures back and forth as in the middle of display lists, loads vertices that it doesn't necessarily need, load the same texture multiple times. I don't know how much of these courses were designed by hand and how much of these were designed with a tool set. Again, that course definitely suffers a lot from unnecessary loading. So with this all finished now, though, and that tangent wrapped up, we'll take a look at some of these section views and see what we're dealing with. So section 1 north, we're actually going to hide everything and just look at section 1 north. Oh goodness, no. Just look at section 1 north. So again, this is the surface, section 1, and this is the direction of north, y positive. So you'll see a lot of things over here that we definitely cannot see. If we're over here and the castle is blocking our view, there's no way that we would be able to see these objects. But again, we're doing this in a very rough manner because in order to get rid of these from the display list here, again, in order to remove these objects, all I need to do is delete them. So I can just go through, select multiple ones at a time, just delete them, and making sure not to mess up this hierarchy here. There's a whole bunch of objects down here. Do not delete these. Leave these alone. You'll notice that these objects are linked to them. For example, here's section 1 north. It moves the whole ding dong thing. When Overcart exports the section views, it uses this. So it goes section 1 north, all the children, it makes a text file, and then later the actual program will use that text file to create the section views in the FedEx command language that it needs to be in. So as you can imagine, this is a tedious process. It takes a long time. Let's say though, oh goodness, I messed up. I can see these. I need to put them back in. So as I said, if I've deleted too much, it takes a lot longer, unfortunately. But it's not impossible. I would bring the course master objects back into view. Select the objects that I can see. Let's say I could see the grass and those two things here. Then I have a clone objects button. A whole lot of buttons here, but these just are very basic functions that help automate some of the processes to make this quicker. Clone objects, we're going to click, it says finished. We'll now hide all of the course master objects again. And in something called temp section, you'll now see the parts that we hit cloned for, and they're named the same as they were before, which is important for the section views. It needs these names to be unique. We would take these, just drag them back into section 1 north, and now the exporter would be able to export those object names again. So when Overcart puts everything together, it uses these unique object names and figures out where they were written into the ROM and then uses the segment addresses to create the display lists. So that's why everything needs to be named something unique. These Mac scripts take care of that for you. If you were doing this in something other than 3ds Max, that would be another part that would be, again, extremely tedious. So these are all the steps that you have to take. It's a lot of work. If you're watching this and you can think of a better way to do this, please let me know. I would love to not have to go through all of this hassle. It's very easy, very straightforward, does not take a lot of time. Or rather, that is the issue, though, is that it does take a lot of time. It's just sitting here, mundane, clicking, deleting, zooming, rotating cameras, trying to figure out, can I see this, can I not see that? Is 1500 polygons too many? Can I get away with rendering all of that? It's a lot of work that I'd rather not do. But unfortunately, if you want to design a course for Mario Kart, that seems to be the process you have to take. So again, hopefully this has been informative if that's what you were here for. I appreciate you taking the time to watch. And again, I want to take the time to thank all the people here for all the knowledge that they've contributed, which has enabled us to be able to create the few custom courses that we have. Hopefully we'll continue pushing this and finding new things, and we'll be able to see some more custom courses coming out in the future. So again, thank you so much for taking the time to watch through this, and I hope you enjoy the rest of your day.